Hello, Algebra 2 students. This is a video for example 4 for topic 1, lesson 1. We're going to identify where a function is increasing or where it's decreasing. For what values of x is g of x equal 2 minus the absolute value of x increasing? For what values is it decreasing? Well, if we have the graph, looks like they use a table of values, which is not a bad idea for an equation like this. It's kind of a weird equation. So they plugged in -2 all the way through 3. I'm sorry, -3 through 3, and got these values for y, g of x. And they graphed it, and they were able to graph that it's an inverted absolute value function. That's because of the minus on the outside of the absolute value, and 2 as a maximum. So I'm already answering some questions for what is showing up here. Let me go right to their work, though. It's nice to have the graph. We can tell where it's increasing and decreasing once the graph is sketched. Increasing. It's increasing on this side of the graph from x values. Again, that's what they wanted us to find. For what values of x is it increasing? And it's increasing from -infinity all the way up till 0. And then it's decreasing from 0 all the way up to infinity. Let me go back. The values of g of x are increasing from -infinity to 0, interval notation with the parentheses because it's exclusive, and it's decreasing from 0 to infinity. And even though they didn't ask it up here, they decided to, they want to have us learn about maximum and minimum. So let's see what they wrote. The point at which a function changes from increasing to decreasing, that's going to be a maximum point. And if it's the other way around, if it changes from decreasing to increasing, that's going to be a minimum point. You might look at it and say, well, that's the high point. Well, maximum, another way we want to think of it is, as it changes, as a function changes from increasing to decreasing, that's going to be a maximum. This graph has a maximum value of 2 when x equals 0. Okay? Now they already want us to try it. Here's two different equations. Maybe we can do one at a time. Looking at this equation, x squared minus 4x, for what values of x is this function increasing, and for what value of x is it decreasing? Click pause if you want to give it a shot, and then come back when you're ready. I believe I have set this up right here. Now, I'd like to have the graph of this. I know it's a parabola because it's written, it's a quadratic equation, so that's helpful. It's got a positive x squared, so I know it's got this going on. Now, I just have to know where is this going to be, right? I could use some graphing software, but let me go back to doing the negative b over 2a. Negative b is 4 over 2a. A is 1, so I know it occurs at x equals 2. That's where the maximum or minimum, and I've already stated since this is a positive x squared, it's going to be a minimum at x equal 2. Now, where along this axis of symmetry is it? You can plug in a 2. 2 squared minus 4 times 2 is 4 minus 8. 4 minus 8 is -4, so what happens at -4? 1, 2, 3, 4. And the graph's going to come down, probably steeper than this, and go up. Again, the question I was trying to answer, what values is it increasing or decreasing? So my sketch doesn't have to be that great, but I can see that it's decreasing from -infinity to 2, right? We're looking at the x values. It's coming down from -infinity to 2, so I'm going to write that. -infinity, that's a terrible, terrible infinity symbol. That's better. -infinity to 2, but it doesn't include 2. And then it's increasing from 2 and up. I should probably be careful of which way I worded that, because I think the first thing they asked for is which values is it increasing. Yeah, for what values is it increasing? it's increasing for this range of values, and it's decreasing for that range of values. And did they ask about where it equals 0? Because it's not increasing or decreasing right here. Now, do you remember? Is it a maximum or a minimum? Well, you can tell from the graph, right? You can tell from the graph that it's a minimum, but they wanted us to consider as it goes from decreasing to increasing means it's a minimum. All right, I think I answered way more than I needed to. Let's look at their answer. The values of f of x are increasing on the interval from 2 to infinity, and it's decreasing from the interval from negative infinity to 2, exclusive. All right, if you want, you can click pause and give this one a shot, and then click play when you're ready. This is a different type of equation. I also have this one set up right here. Looking at this, I see that it's not x squared, it's just an x, so that's a linear equation. It's going to be a line. And then I think about what I did with algebra back in the day. That's written in y equals mx plus b form, right? So let's use that. The minus 3 is the y-intercept, so it's going to cross right there. And it's going to have a slope of negative 2. Down 2 over 1. Down 2 over 1. The opposite of going down 2 and over 1 is to go up 2 and over the other way 1. Up 2 over 1. Up 2 over 1. Now, what was the question? Where is the function increasing and where is it decreasing? Well, because it's a linear function, it's always either decreasing or increasing. Going left to right, it is always decreasing. So it's never increasing, and the interval for where it's decreasing is from negative infinity to positive infinity, because it's always decreasing. Let's see what they wrote. The values of f of x are never increasing. It is decreasing on its domain, the interval from negative infinity to positive infinity. Okay? Hope that helped you out with doing the following problems. Quite a few. You might want to check with your teacher to see which ones they assigned. 21, 26, 31, and 14 through 17. That's it for this video. Have a great day.